All right, week 1 notes continued. Now we're working on exponents and shortcuts. In Math 99, you learned some vocabulary. For instance, in this example, the 5 is called the base of this exponential expression. This is called the base, the big number. B for big, B for base. The small 7 that's raised is called the exponent or the power. Exponent, and sometimes we say power, but in this case we'll probably use exponent most of the time. What does it mean when we raise a base to an exponent? Well, the base tells us what number we're multiplying over and over again, and the exponent tells us how many of that number we're multiplying. So notice the 5 is written over and over again. How many times? 7 times. 1, 2, 3, 4, 5, 6, 7. So we can calculate this if we really wanted to. We'd go 5 times 5 times 5 times 5 times 5 times 5 times 5 in our calculator, but that takes a really long time. So instead, if we want to find out how big 5 to the 7th is, we can go 5 power up. Now on most of your calculators, the power key is this upside down V. On some of your calculators, it might be a button that looks like this, y to the x power. Y to the x power. Once in a while I've seen x to the y power, but it's usually y to the x power. So either you have this upside down V, like so, or you have the x to the y or y to the x. So I'm going to show you how to enter that. We put in the 5, press your power key, whatever it looks like, and again mine is this upside down V. It looks like this in my calculator. Yours might look differently depending upon your calculator. And we're powering up to 7. My calculator is now going to do 5 times 5 times 5 times 5 times 5 times 5 times 5. It's going to be a big number, 78,125. Now, I can put down the answer to this if I want, 78,125. But in this case, we're just seeing what 5 to the 7th power means. Alright, now here's an example with a variable. It says take some number, mystery number A, and multiply it by itself 4 times. It means A times A times A times A. Now I can't answer this and I can't do it in my calculator till somebody tells me what A is. Alright, so that's what a base, again A in this case is the base, and the 4 is the exponent. So what happens if we have two exponential factors that are multiplied together? Well, let's look at A to the 4th. We already know that's A times A times A times A, and that's getting multiplied by, there's that multiplication sign here and here, that's getting multiplied by A to the 3rd power. That's 3 more A's multiplied. Well, how many A's are getting multiplied all together? Take a look. There's 7 of them. 1, 2, 3, 4 here, times 3 more here, so it's really just A to the 7th power. Well, what's the shortcut? What if you didn't want to write out all those A's and count them? What do you do with the 4 and the 3 to arrive at the answer? Well, you add them. So over here we have the general form. If you have the same number times itself, but that number is raised to a power in each case, then you just add up those exponents and it'll tell you how many times that number needs to get multiplied by itself altogether. I'd also like you to write the word explanation for this right next to this. We're going to have to write small. When multiplying like bases. When multiplying like bases, just add the exponents. Alright, that's our rule for multiplying like bases. It's called the product rule. Alright, let's look at the quotient rule next. In this case, I've got b to the 5th power divided by b squared. Let's do an example first with real numbers. Let's say I had 4 to the 4th power over 4 to the 3rd power. Well, that would mean I had 4 times 4 times 4 times 4 on top over 4 times 4 times 4 on the bottom. Now, think about what's going to happen here. These 4's will cancel out because 4 divided by 4 is 1. These 4's will cancel out, and these 4's will cancel out. That just leaves a single 4 on top. Well, what power is 4? Just plain 4? It's 4 to the first power. If you ever have just a plain number and you're wondering what power it is, a plain number, the power is always 1. We just don't usually put it there. So let's see what the shortcut would be. If I didn't want to write out all these 4s divided by all those 4s, remember it's division, what do I do with these exponents, 4 and 3, to get 1? I subtract them. Because 4 minus 3, 4 4s minus 3 4s leaves 1 left over. So this is why we get 4 to the first power. Let's look at an abstract example. If I have 5 b's, b to the 5th power, divided by 2 b's being multiplied, b to the 2nd power, when I expand it and look at it, b over b makes 1, b over b makes 1. What does that leave me? b times b times b to the 3rd power. b to the 3rd power. What's the shortcut? 5 minus 2. What we're doing here is b to the 5 minus 2. And this is how we get b to the 3rd power. Alright, here's our general example. If you're dividing two like bases, by the way, that number has to be exactly the same. The base number has to be exactly the same in the top and bottom. Dividing like bases, subtract the exponents. Let's write our explanation off to the side. When dividing like exponents, when dividing like bases, shame on me. When dividing like bases, subtract the exponents. Alright? Next example, the power rule. Alright, in this case, I've got some number being raised to a power inside of parentheses, and then we're powering that number up. Alright, let's do a real number example first. Let's say I have 3 to the 2nd power, and then I want to raise that to the 4th power. Alright, now that means that I'm going to do 3 squared first because it's inside the parentheses. So that would be 9 to the 4th power. And then I would take my calculator and do 9 times 9 times 9 times 9, or the shortcut, 9 power up to 4. Let's turn it on first. 9 power up to 4. And I get a big number, 6,561. Well, there's a shortcut. What I could have done is think about it this way. This is 4 of these being multiplied. 4 3 squareds being multiplied. It's 3 squared times 3 squared times 3 squared times 3 squared. Now this is not looking like a shortcut right now because I lied. It's really not. This is the long way to think about it. And 3 squared times 3 squared times 3 squared times 3 squared. Well, how many 3's are getting multiplied all together? 2 of them here, 2 more here, 2 more here, and 2 more here. 2, 4, 6, 8 3's being multiplied. So another way we could have done this problem right away is to just type 3 to the 8th power in our calculator. 3 power up to 8. And I get the same answer. So how do we get from here to here so we don't have to think about this and we don't have to do this? Well, what do you do with these two exponents to get 8? You multiply them, right? So when you have a base raised to a power and then that's raised to a power, I call this superpowers. We're powering up. We're raising a power to a power. You multiply the exponents. Alright, so here's our general example. C is being raised to a power and that result is being raised to another power. And so in words, when raising a base to a power, then to another power, I can also say exponents, just multiply the powers. Or the other word is exponents. They mean the same thing. Okay.